Welcome sa course natin, particularly statics of rigid bodies. Solve tayo. So, unang problem. So, determine the x and y components of each of the forces shown. Meron tayong 50-pound force sa positive y and negative x-axis, measured 28 inches to the left, the origin O, tapos 96 inches above the origin O. 29 pounds, measured, so 84 inches to the right and 80 inches above the origin O. At yung isa pa, 51-pound force, 48 inches to the right and 90 inches below the origin O. Yung mga measurement dyan, gagamitin natin para makuha natin yung angle with respect to the horizontal. Yung gagamitin natin para makuha yung x and y components. So para makuha yung mga components denoted ng f of x, kukunin natin yung cosine ng theta ng force F, in which yung theta is measured from the horizontal. While yung f of y, sine theta naman ng force F, measured din ng theta from the horizontal. So yun. So para sa force na may magnitude na 50 pounds, yung theta pwedeng makuha relationship ng opposite side over adjacent, yung mga measurement kanina. Kaya tangent theta is equal to 96 over 28. At yung theta, arctangent ng 96 over 28. Kaya para sa horizontal component or x component na f of x, so 50 cosine arctangent 96 over 28. Para naman sa vertical component, yung y component na f of y, so equal naman yun sa 50 sine arctangent 96 over 28. So f cosine arctangent ng a over b. So yung a over b, yun yung measurement natin, and then yung f, yun yung force. Kasi marami tayo, so ganito na lang, no? Display yung column. So substitute natin, calc. So f is equal to 50, and then a is equal to 96, tapos yung b ay 28. So unang sagot, so yung cosine, so 14 at 48. So f of x is equal to 14 pounds, f of y is equal to 48 pounds. So yun yung component ng forces natin. So tandaan, kapag yung x component, kapag yung theta natin is measured from the horizontal, dahil nga x component, so cosine yung gagamitin. Dahil yung angle natin, adjacent side niya yung x-axis, kaya cosine. Opposite side niya naman yung parallel dun sa y-axis, kaya sine para dun sa y component. So solve pa ulit tayo. Para naman dun sa force na may magnitude na 29 pounds, yung theta ganun ulit, no? So 80 over 84 naman dito. So para sa horizontal component, so 29 cosine arctangent 80 over 84. Y component, 29 sine arctangent 80 over 84. So solve natin, yung f ay 29, yung a is 80, tapos yung b is 84. So para madali mag-solve, so 21 and 20. So x component is 21, y component is 20. So sa 51 pounds naman, so ganun ulit, yung arctangent, so yung theta arctangent ng 90 over 48. So 51 cosine arctangent 90 over 48. Yung f of y, 51 sine arctangent 90 over 48. So solve natin. So 51 yung f, a is 90, b is 48. So 24 at 45. So yun yung x and y component natin dun sa force na 51 pounds. So ito yung mga sagot natin. Ito yung x and y component ng mga forces shown. So yan yung typical na pagsosolve natin. So pwede nating gawin or gamitin yung function sa calculator para makuha natin yung rectangular coordinates. Yun yung x and y component. So galing to dun sa polar coordinates, yung r tsaka yung theta. Yung r dito, yung given na force. Tapos yung theta, yung angle with respect to the horizontal or x. Kaya yung unang value na makukuha natin ay yung x dahil yung theta natin, kunuha natin from x. So para sa 50-pound force, yung tangent theta equal ulit sa 96 over 28. So arctangent is 96 over 28. Kaya yung para sa horizontal component or x component, and then yung vertical or y component, so solve natin. So rectangular coordinate, so f. And then arctangent ng a over b, kaya rin kanina. So f is equal to 50. A is equal to 96. So 96 over and then 28. So yung x and y component natin, yan nakalagay na. So x is 14, y is 48. Para naman sa 29-pound force, so arc tangent 80 over 84, so F is equal to 29, A is equal to 80, B is equal to 84. So X and Y component is 21 and 20 pounds. So para naman dun sa 51-pound force, so 90 over 48, so 51, and then 90, and then 48. So X and Y components are 24 and 45 pounds respectively. So pwede rin natin gamitin dito yung isa pang way, yung sa complex mode naman sa calculator. So yung form natin doon, yung R or force and then yung angle theta is equal to X plus YI, or sa complex form A plus BI. Yan yung natin, yung form natin, yung F or yung force angle theta or R angle theta is equal to X plus YI or yung A plus BI. So para sa 50-pound force, ganun ulit yung arc tangent, yung kailangan natin dito yung theta. So sa calcu, complex mode, so ganun ulit, lagay natin F, tapos yung angle, arc tangent ng A over B ulit. So para i-calculate na lang natin. So F is equal to 50, A is equal to 96, B is equal to 28. So, yun yung form natin. So, yung constant, yung 14, tapos yung coefficient natin, so 48. So, yung X component is 14 and then yung Y component is 48. So, sa 29, so ulit natin. So, F is equal to 29, A is 80, and B is 84. So, 21 tsaka 20 pounds. Then last, so 51 pounds. So F is equal to 51, A is equal to 90, B is equal to 48. So 24 and 45. So depende sa inyo kung ano yung pinakamadaling way para sa inyo sa pag-solve nun. Pwedeng yung conventional, pwedeng yung kukunin natin yung rectangular coordinates, tapos yung isa, yung sa complex mode sa calculator. So next problem. So the hydraulic cylinder BD exerts on member ABC a force P directed along line BD, knowing that P must have a 715 Newton component perpendicular to member ABC. Determine una the magnitude of the force P, tapos yung isa ba yung its component parallel to ABC. Yung force P daw natin along BD, yung member BD, at yung member ABC may perpendicular load na 750 newtons. At ito yung mga angles. Ito yung force P along BD. Tapos may perpendicular load dun sa member ABC, yung component natin, perpendicular sa member ABC, which is 750 newtons. So ito yung mga angles. Ito. Tsaka ito. So in 30 degrees, may 60 degrees kasi tayo dun sa member ABC, tapos yung angle between member BD at member ABC is 50 minus 30, so may 20 degrees tayo dito. So kukunin natin yan para dun sa pagko-compute natin dun sa member ABC pati dun sa force P. So gamitin natin na axis yung member ABC at yung 750 Newton na component ng force directed along BD. Kaya yung 750 equal sa P sine 20. So solve natin. So 750 over sine 20 degrees. So yung value ng P, so store natin sa A is 2,192.8533 and so on newtons. Next naman, so yung force sa member ABC, so cosine naman, no? So cosine ng P. So P cosine 20 degrees. So yung P nakasur sa A, so cosine 20. So members or force or yung component parallel to ABC, so 2060.6080 and so on newtons. So ito na yung sagot natin. So yung P na may component na 750 newton perpendicular to ABC is 2,192.8533 newtons. Tapos yung component niya parallel to ABC ay 2,060.6080 and so on newtons. So next problem, yun, determine the required tension in cable ABC knowing that the resultant of the three forces exerted at point C of boom BC must be directed along BC. The corresponding magnitude of the resultant, yung isa pa, yung una, yung required tension in cable ABC, denote natin ng T sub AC. Tapos yung magnitude ng resultant na directed along member BC. So ito yung mga given na forces. Tension for cable AC, yun nga yung T sub AC. At yung resultant, directed at boom BC. So ito yung mga alternate angles, yung 35 degrees tsaka yung 65 degrees. So ito pa nasa 25 degrees, pati yung given na 50 pounds tsaka yung 75 pounds. So pwede natin makuha yung resultant gamit yung components along the x and y axis, parang Pythagorean theorem. Na RBC squared, yung RBC yun yung resultant directed along BC, and then RX squared plus RY squared, yung components ng resultant. So at yung R sub x is equal to 75 sine 25 degrees. So yung 75 dyan, positive dahil nasa positive axis, yung axis natin dun sa point C, yung origin. So positive natin to the right, so kaya positive 75 sine 25 degrees. Tapos negative dahil to the left dun sa origin, dun sa point C. So TAC sine 65 degrees naman. So sine dahil opposite yung component nila, yung parallel dun sa x-axis, kaya sine yung gagamitin. Then yung RY, so positive naman natin yung nasa taas nung origin C, kaya TAC. Cosine naman dahil adjacent niya yung axis parallel dun sa Y. So cosine 65 degrees minus 50 degrees. So directed downward minus 75 degrees or 75 cosine 25 degrees. So cosine din dahil nga adjacent naman yung parallel dun sa Y axis. So isa pa yung equation natin dahil alam natin yung direction ng resultant, which is 35 degrees about the vertical. So therefore, tangent 35 is equal to yung opposite, which is yung parallel dun sa x-axis, kaya r sub x over r sub y, yung adjacent naman. Adjacent dun sa angle, so r sub y. So substitute natin yung r sub x tsaka yung r sub y. So 75 sine 25 degrees minus TAC sine 65 degrees over TAC cosine 65 degrees minus 50 minus 75 cosine 25 degrees. So divide natin sa tangent 35 degrees both sides. So arrange lang natin. So add na rin natin or subtract both sides yung mga required values para yung TAC na lang yung nasa left side. Kaya TAC is equal to 75 sine 25 degrees over tangent 35 plus 50 plus 75 cosine 25 degrees. Then over, so cosine 65 plus sine 65 over tangent 35 degrees. So 75 lang yan sa calculus, 75 sine 25 degrees over tangent 35 plus 50 plus 75 cosine 25 degrees over cosine 65 plus sine 65 over tangent 35 degrees. So yung tension sa cable AC, so start na sa A, so 95.0751 pounds. So meron tayong sagot dun sa isang tanong, yung required tension in cable AC. So para naman dun sa resultant, so gamitin natin yung sa mga components. So therefore, R sub x is equal to, so 75 sine 25 degrees minus 95.0751 nakastor sa A, sine 65. So R sub x is equal to negative 54.4709 pounds or 54.4709 pounds leftward. So, pakaliwa yung ano natin, kagaya nga nung nasa figure. So para naman sa R sub Y, substitute din natin yung value ng TAC. So A, na yun yung nakastore sa A na TAC, cosine 65 minus 50 minus 75 cosine 25 degrees. So para sa RY, so in-store lang natin sa C, so negative 77.7925 and so on pounds. Dahil negative, so downward. So tama yung direction natin, leftward, downward, yun nasa figure. So substitute natin yung values ng R sub X at R sub Y sa equation para makuha yung resultant natin directed along BC. So ito yun, so nakastore na lang to sa B, so B squared, so square root ng B squared plus C squared. So resultant directed along BC ay 94.9672 pounds. So kaya yung sagot natin para sa tension sa cable AC at yung resultant na directed along boom BC. So 95.0751 pounds tsaka 94.9672 pounds respectively.